All right. Our goal for this video is to go through the different types of forces. Our objectives are to analyze data to describe the mathematical relationships between the net force on an object, the mass of the object, and its acceleration, and use Newton's laws to predict the motion of macroscopic objects. So we can sort forces into two different categories, contact and non-contact forces. So a contact force is where the interaction between objects due to direct contact with each other. A non-contact force is the interaction between two objects that are separated by some distance. So this orangutan picture shows both contact forces and non-contact forces. An example of the contact force would be where the orangutan's hand meets the rope, where there's direct interaction. And a non-contact force would be gravity pulling down on the orangutan and the rope itself. So we're going to continue to define the different types of forces, and you will be held accountable for each of the words bolded in black. So weight, the downward force experienced by objects resulting from the gravitational attraction to Earth. So what you see on the scale is your mass times acceleration by gravity. And the gravitational force is a non-contact attractive interaction between two objects. And the center of mass is the point representing the mean position of an object's matter. So whenever we want to calculate weight, we can say it as the weight is equal to the mass of an object times gravity, and the mass should be in kilograms. So if you bounce a basketball on a court, you can obviously see the change in shape of the basketball and the resulting movement of the basketball going from the down back up. But this deformation, or a change in shape, also occurs on the basketball court, but in a smaller amount. So deformations occur in objects due to the application of a force, and we can have this with springs. So the spring constant is the spring's resistance to deformation, and there's Hooke's law. The size of a spring's deformation is proportional to the applied force. So we can say that as equal to negative k being the spring constant times the change in length of the spring. However, we won't focus too much on the spring force. So then we have tension and electric force. So tension is a contact interaction and is the pulling force on a rope, cable, or chain exerted along its weight. So here we have a cat that is trying to climb a rope. You have the weight of the cat pulling the cat down as a force, and then you have the tension on the rope in the opposite direction. An electric force is the non-contact interaction between two objects having an electrical charge. This could be within the atoms of the rope itself. One type of force we will deal with a lot are surface forces. So surface forces are the spring-like interaction between two surfaces in contact with each other. So friction is the parallel component of the surface force, otherwise known as the x component, and then the normal force is the perpendicular component of the surface force, otherwise known as the y component. So if I have this box that is saying stationary, both my surface force is pushing down and my normal force is opposite of it, and there is no movement. However, if I have a box that's moving, that's when we start seeing the surface forces not in just one direction. So in this case, my norm would still be pointed up from the object itself. The friction would be in the negative x direction because the box is moving to the positive x direction. And my surface force would be the force that the table is applying to the box, and that would be a combination of friction and the normal force. There are two different types of friction. There is static friction, the friction for attempted motion between two surfaces or when things don't move, and kinetic friction, the friction for surfaces moving relative to each other. So that means there are two different equations that we use. So the friction component of the surface force is represented by little f. Mu subset s is the coefficient of static friction. These are constants. They also do not have labels. Mu does not have a label, so that is okay when it's unlabeled. And N is the normal component of the surface force. In static friction, this side is greater or equal to the friction. In kinetic friction, we have the same components, except for there's a different coefficient, where the coefficient of kinetic friction, and then N is the normal of the surface force. Each material will have different coefficients of frictions, and either you will be given them in the problem or you'll be asked to find them from other object items being given in the problem. So it is not something you'll have to memorize for each material. And that's how I have today. Go ahead and start the weight lab, where you can explore how weight changes depending on the planet you are on.